Apparently there's a chance that there's going to be an outflux from some of the upstairs meetings, so we may get a lot of people coming in the next 5 or 10 minutes or so, but thanks very much indeed to all you guys for turning up. Our workshop is going to be about using ecosystems and traditional knowledge to help people adapt to climate change, building the evidence base. My name is Dave Holden. I work for Conservation International. We're co-convening this with the International Institute for Environment and Development, and it's supported by our partners, the World Bank and UNDP. And it's probably the penultimate, or certainly one of the last workshops in IUCN's EBA journey. If you had a chance to follow any of that journey, it's been fascinating, and you'll have heard about some of the great strides that have been made in terms of producing best practices, in terms of guidelines for EBA, and some examples of how ecosystems can actually help people adapt to climate change, the role that traditional and indigenous knowledge can play in making that adaptation actually effective. So in short, what you will have heard if you followed any of that journey is what we basically know about EBA. What we want to do in this workshop is get at the flip side of that. So what don't we know about EBA? What are the known unknowns? What are the gaps in the evidence base? And it's absolutely critical that we start addressing these and doing it soon, because EBA is a rapidly moving field. The Green Climate Fund is operationalising. There's going to be potentially very large sums of money coming down for adaptation. We want EBA to be able to achieve its potential, then we need to start filling those gaps. And that's even more important in terms of being able to then take our arguments to decision makers, so actually show them how EBA can work, demonstrate how it can work, so that EBA becomes more than just something that decision makers appreciate in this Congress or in the conservation community more broadly or in environment ministry, but it actually starts to become mainstream into any country's adaptation and development dialogue. We've got 4 pretty simple objectives that we're going to try and get at today. We want to outline the potential role of EBA and traditional knowledge in climate change adaptation. We want to review the current evidence base, the effectiveness of EBA. We want to share lessons learned. This is a key piece from the field in building that evidence base by learning by doing. And then what we want to do is we want to use some of your brain power to start identifying some of the key gaps in that evidence base. To do that, over the next couple of hours, we are going to we've got the workshop will take place in 3 sessions. First one is going to be basically just setting the scene. So I'm going to start very briefly and just give an overview of EBA. I'm going to hand over to Christina Swiderska, who's going to talk about traditional knowledge, agro-biodiversity, and that role in EBA. Then we start putting some of the meat on the bones of this workshop, and Gillis Rowe is going to talk about present results of the first systematic study, the first systematic review of the peer review and to some degree the grey literature on whether or not EBA is actually effective. It's rather an important question for us to get a handle on. Then finally in the 3rd session, this is where we get you guys involved. What we're going to do is we are going to break up into small breakout groups. It can be necessarily short because we just don't have that much time obviously here. And each of those breakout groups will be facilitated by one of our 4 expert panelists, who are James Watson, who's head of climate change at WCS, is Keith Allison, who is head of the Climate Change Adaptation and Terrestrial Ecosystems branch of the Division on Environmental Policy Implementation of the UN Environment Programme, trying to do that in jet lag. Valerie Hickey, who's a biodiversity specialist from the World Bank, and Alejandro Olmedo from the Association for Nature and Sustainable Development. I'll explain a little bit more about those breakdown groups when we get there. That's the plan, so we can see how far we can get in the next 2 hours. So what I'm going to do is just give a very brief overview of EBA for those who haven't had a chance to follow that EBA journey. It's always useful, I think, when we just very rapidly when we start, is just to understand why we're here, why we're talking about adaptation. We're still setting records. 2011 was the biggest amount of CO2 emitted so far. That followed on the tails of 2010, which was at that point the biggest amount of quantity of CO2 emitted so far. So we're doing an awful job when it comes to mitigation, and that's having nasty implications for our planet. This is one of those implications is that we had over the last couple of weeks the lowest recorded extent of Arctic ice ever. There's a lot of us who are currently swimming, shivering, or sweating in all sorts of extreme temperatures, whether it's the Midwest drought in the US or whether it's floods again in Southeast Asia. And that's nothing new. We've always had extreme events, we always will. Some people live in areas of the world where they're far more common. And climate scientists have always said that you can never attribute a single extreme event to actual climate change. Even that is now beginning to change because the magnitude and the frequency of some of these extremes means that you can now, using statistics, actually get an attribution of individual extreme events to climate change. And of course, not every extreme event is due to climate change, but where they are, they're beginning to be able to get at this. So, adaptation is an absolute no-brainer. We have to do something about this. There's many ways to simplify horribly. There are many ways of doing adaptation. You can build things, seawalls, levees, water filtration plants. You can input on early warning systems. You can buy insurance, for example. Because we all like categorizing things, we generally put them into a couple of bins. So we have hard options, which are basically anything to do with pouring concrete and building infrastructure. And then soft options are more about capacity, about information, about policy. Of course, again, the reality on the ground is that good adaptation doesn't deal with just one option or the other. It's a process that selects the most effective actions from a range of options for a given adaptation context. So it doesn't have us be necessarily a start and end, it's an ongoing process. Now, EBA, we kind of first heard that term roughly about 6 or 7 years ago now. It's nothing new necessarily in itself in that it builds on some very established components of, for example, community-based natural resource management. But its appeal and its power derives from the very simple observation that we all live in complex socio-ecological systems. I emphasize all, because we tend to forget that to some degree in the developed world, but obviously in the developing world, that link between people and the ecosystems that they're a part of is even more explicit. We have something like 1.4 billion people living in extreme poverty still. It's got a little bit better, but still in the developing world. And about 70% of those live in rural areas, so their lives and livelihoods are absolutely dependent on the natural resources, the green infrastructure, whatever you want to call it, that's around them. So in that respect, EBA is a no-brainer. It simply makes sense to use ecosystems and natural infrastructure to help people adapt, assuming it does. So can we define it? There is no absolutely formal definition for EBA. That's one of the many interesting issues about being in this field, but far and away the most popularly used definition is this one from the ad hoc technical expert group at CPD. I'm not going to read it to you, but 2 things to pull out. One, it's a process. And number 2, and this is key I think, is that the beneficiaries are people, the customers of EBA are people. What we're actually seeing on the ground is a fairly wide interpretation of that definition when it comes to projects. So, and again, I'm simplifying horribly, but bear with me. If you imagine a gradient where we have people on the left and biodiversity on the right, we're seeing some projects on the right-hand side where the goal is very much to reduce the vulnerability of biodiversity. So the customers are species and ecosystems, and there is sometimes a co-benefit of reducing the vulnerability of people. Whereas on the left-hand side, we have projects that are basically defining where are people vulnerable to climate change, so the customers are people, and the potential for reducing the vulnerability to climate change of species and ecosystems or other kind of conservation outcomes is a likely, but certainly not a guaranteed, co-benefit. Now these all come under this, or have come under this umbrella of EPA, and I'm not going to try and define whether it should be one side or the other. But what we have to understand as a community is this does have implications for where we actually work. So if we target vulnerable people, and then we say, well, what ecosystems are there around that can help those people adapt? The map of where we work in any given landscape or seascape is going to be very different to if we say, right, where are the vulnerable ecosystems or high biodiversity, and then where are people that are being helped by those ecosystems? So it does have huge implications for where we work, and there's implications for the uptake of EBA. So for example, there are plenty of large montane forests, watershed forests that aren't necessarily threatened by climate change, but that are providing sustained freshwater services to developing world cities that are increasing in size. And so if we target those, if we go with the vulnerable ecosystem approach, then we risk missing those really, really important, potentially important areas in which EBA can help. So cities of tens of millions of people, where are some very, very poor people and some very, very vulnerable people. So what I want to emphasize here is that there's still the need, I think, to have more discussion within the conservation community, within the adaptation community, in order to refine not necessarily the definition, but the interpretation of that definition. So all we're going to do is just to wrap up, because I want to give plenty of time for particularly the field presentations that are going to come in the next session. Is I'm just going to flag up three areas where I, at least in the work that I've been doing over the last couple of years, have really run into issues in terms of the evidence base for EBA. One of those is our ability to basically quantify the adaptation service that is being provided, so the storm attenuation service, for example, is actually still pretty limited in many contexts. And even for mangroves, where we have a very large body of work, yes, there's good evidence that mangroves reduce loss of life. Certainly after storms, there's even some indication under tsunamis. There's empirical work that suggests mangroves can attenuate storm surge in the range of 50 to 70%. But there's also a lot of research that says that it's hugely dependent on the context. It depends on the bathymetry, it depends on the species of mangroves, it depends on the soil, the substrate, you name it, coastal topography. So what we really need are frameworks that we've got, that data can go into, that inform the conditions under which an adaptation service is provided by an ecosystem, and gives us some confidence in being able to predict what that adaptation service is in any given context. In the vast majority of cases, we can't do this one. Second one quickly is key question. Yes, we have an ecosystem that's providing an adaptation service. Beautiful. Is it going to be there in 20 years or 50 years under climate change or other forms of global change? Classic example here is there are certainly plenty of montane cloud forests that are providing, or that have the potential to provide adaptation services to people downstream, farmers, communities, whatever it needs to be. But if those cloud forests are highly vulnerable, as they are, to climate change, then there's a real risk that that adaptation service is going to be degraded and attenuated and eventually disappear. And then finally, in terms of cost effectiveness, there's a good amount of economic analyses now that have been done, at least in some areas. For example, looking at coral reef protection for Pacific Islands in comparison to what it would cost to bung in levees and do all the hard infrastructural work. The problem is that a lot of those studies are often of variable quality, and there are a lot of methodological inconsistencies between those studies, and they often fail to account for all the costs and benefits that they really should do when they're doing their analysis. And so this is often only for a really small subset of possible EBA contexts. So again, we now need tools and the data that allow comparison of engineered ecosystem options. So those are just three very quick areas, gaps in the evidence base that I'm at least struggling with in some of the projects that I'm working on. So just for me, a very quick take home is, I think there is still some need because of that issue about where we actually do our work in terms of the interpretation of the definition of EBA. We've got to look at the evidence base. There's a huge amount of stuff that we still need to learn. We're going to hear about a lot more about that today. Haven't had a chance to talk about it right now, but robust, I'm a huge fan of robust monitoring and evaluation. And in the end, we funders don't really provide enough money for it. We're not really into this as much as we should be in terms of M&E. It's absolutely critical for adaptation, for ecosystem-based adaptation, that we do this and we do it robustly. The other side of that is we don't have time for theory to catch up with us. We can't wait 20, 30 years until the science is there and we have these beautiful biophysical functions to describe everything. We have to do learning by doing. We actually have to start doing this stuff in the field. Same as what we'll learn about, hear about in the next session after this. On the stop, what I'd like to do now is welcome Christina Squidurska from the International Institute for Environment and Development, who is our co-convener here. Christina is going to talk about, if I can find my notes, the name. What I could do is just open it up and then you'll see what she's going to talk about. Thank you.
Thanks, David. I think that was pretty impressive considering how badly you're suffering from jet lag. I have to say I've been awake since 2 a.m. for the last 2 days, so I'm quite tired. Anyway, so this is my presentation, the role of traditional knowledge, agrobiodiversity and biocultural systems in adaptation to climate change. How do you move the slides on?
Just the arrows on the keypad.
Okay. All right.
Thank
working. So why do we need to look at the evidence base and to improve the evidence base of the role of ecosystems and traditional knowledge in adaptation? As David pointed out, there are hard and soft approaches to adaptation, and generally the hard approaches have dominated in terms of what national adaptation strategies. For example, physical concrete barriers, and also adaptation based on agricultural intensification and ecosystem degradation. So the other sort of indicator of whether ecosystems are being taken into account is whether leading climate change economists are taking it into account, and up till recently they haven't been. As this study on the economics of adaptation to climate change in 2010 by the World Bank and IBRD paid limited attention to ecosystems and traditional knowledge, but hopefully we're moving away from that within what the latest is of World Bank economists' thinking. But encouragingly, a review of national action programs for adaptation projects in 2009 found that over half of these projects now feature ecosystems or ecosystem services. At the same time, there's still very limited attention to traditional knowledge in general. The IPCC's last assessment recognised the role of traditional knowledge in agribiodiversity and adaptation, but in the discussions in the UNFCCC COP, its TK is still very marginalised, and its potential doesn't get the recognition it deserves. Equally, I haven't reviewed all the reports that the EBA, Ecosystem-Based Adaptation Community, produces, but there's the ones I've seen have tended not to address traditional knowledge very much. I think we really need to increase research on the role of traditional knowledge and ecosystems, and how traditional knowledge can improve the role of ecosystems in adaptation to climate change. There are 350 million indigenous peoples, roughly, including pastoralists and farmers, for example, and very often where you find the highest cultural diversity, you also find the highest biological diversity. And many of these peoples are still managing and conserving rich variety of crops and livestock. And often they live in the harshest of the environments, in marginal agricultural lands, which are most impacted by climate change. Being harsh environments already, they're facing the real extremes that the more mainstream agricultural lands aren't yet facing. So what this does is having this biocultural diversity coupled with these extreme selection pressures means that these people are already facing extreme climate events more so than others. And because they depend most directly on natural resources, they're adapting their agrobiodiversity, they're adapting their ecosystems already, and improving them, and improving the adaptive capacity of ecosystems. So it's not just about them using ecosystems to adapt, but they're actually improving ecosystems so that ecosystems play a bigger role in adaptation. And these processes, which are often in high mountain areas or coastal areas, as I said, marginal environments, provide a vital gene pool for future adaptation in agriculture more generally, in mainstream agriculture, which so far hasn't faced such extreme climate change impacts or climatic changes. So I think there's a real need for us to look at these centres of adaptation, these biocultural centres, and recognise the role of ecosystems stewards in those centres in enhancing the potential of ecosystems for adaptation. Okay, looking at agroecosystems, to highlight the role of traditional knowledge, these are some of the main types of traditional knowledge for adaptation in agriculture. Knowledge about resilient species and varieties, farmers living with and managing species which are facing very strong selection pressures and are adapting to climate change. They often know which species or which varieties have resilient properties to different impacts, whether it be drought or pests or rising temperatures. So there's a huge knowledge about which species, varieties, land races are resilient for different types of climatic impacts or extreme events. I think we really need to recognise that plant breeders aren't just scientists, but farmers and pastoralists are active breeders of crops and livestock, and they're active conservers and they're active selectors, and they're adapting the genetic